All right, so I have a video here of the FRQ questions from today, which is March 26th. All right, so question one, it's the diagram and then the three steps. So first off, totally my bad. Didn't put any axis labels on the diagram. That was silly of me. So it should say energy on the y-axis and the x-axis is reaction pathway. That's a typical, the two axes you're going to see for mechanism-based graphs. Anyway, for the balanced equation overall, all right, if we just add everything up and cross things out, we get A plus 2B produces E, all right? By doing that, we figure out that C and D are both intermediates, all right? C is produced in step 1 and used in step 2, and D is produced in step 2 and used up in step 3, all right? You can have intermediates in the overall reaction, which we don't, and those are our intermediates. Catalysts, we have no catalyst for this reaction. There is nothing that we start with as a reactant and then is also a product at the end. Remember, catalysts, even though they appear in the reaction, they're actually not part of the reaction, but we don't have anything that fits that criteria. Right. The rate law. So, well, we can look by determining that the second step has the largest activation energy. All right, we know that's the rate determining step. So the rate law would be rate equals K times C times B. All right, and that's what I have right there. All right. However, we can't have C in the rate law. As we said, it's an intermediate. All right, can't have intermediates in the rate law. So instead, we know step 1 is fast. All right, and C is produced by A and B. So we can sub C out for A and B, and then we plug it back in, we get rate equals K, A times B squared, right, which makes this trimolecular. All right, and the last part, is this reaction endothermic or exothermic? It is exothermic because our initial energy over here is higher than our final energy over here. So if we were to figure out delta H, it's always final delta H minus, or final H minus initial H. So we're going to have a negative delta H, exothermic. On to the back. All right, so we're given a graph with various points, A, B, C, D, and E, and then they correspond to a H2O2 concentration and some value of time. So if we just look, we have this logarithmic graph versus the concentration of H2O2. All right, so we're not really sure what we've got here, our exponential graph. And then if we look, we start with 0.24 as our concentration of H2O2, and then at point C, all right, it's now 0.12. It's been cut in half, and that went from 8 seconds to 17 seconds. So in 9 seconds, we had a half-life. From A to C was 9 seconds. All right, well, if we look at point D, we are now half of C, so that's another half-life. Well, this half-life went from 17 to 26 seconds, which is also 9 seconds. The first half-life from A to C was 9 seconds, and the second half-life from C to E was also 9 seconds. When the half-life is constant, that means it's a first-order reaction. So what order is this? Okay, it's first order, right? And how do we know? Because the half-life time is constant. And then what is the value for K? What are its units? Well, because it's a first order reaction, we know half-life equals 0.693 over K. So rearranging it, we get K equals 0.693 over half-life. Divide that by 9. It's 0.077. And K in a first order reaction is always going to be just per unit of time. In this case, since time is measured in seconds, it's per second. So 0.077 per seconds. And then last, for number 3, an object that has a half-life that increases after each half-life. The half-life is measured in hours. What are the units for K in this reaction? So when your half-life increases every time, it gets larger and larger. That is a second-order reaction. Right? Half-life continually gets larger. So we know K has to be 1 over concentration times the unit of time. In this case, since half-life is measured in hours, K is going to be 1 over molar hours, or what we have here. All right, so that's the 3 questions. Let me know if you have any other questions. Have a good day, guys.